All right, let's have a look at this next one. Next one is we're going to call it, these are co-interior angles. Now, co-interior is actually kind of a class of angles because we don't just have co-interior. Let me show you what I mean. So if you've got two angles, you have your transversal, this angle and this angle are going to be supplementary. These are supplementary pairs of angles. So you could say, if you were going for this, you could say co-interior angles add to 180, or you could say co-interior angles, you could say, and you could just go supplementary. That would be good. Oh, wait, you must say parallel lines. If you don't say parallel lines, you're out of luck. Comma, parallel lines. There it is. You could also say angle sum, yeah? Sum of co-int angles equal 180 degrees, comma, parallel lines. Anything there would be useful. And of course, these two do add to 180. And these are called co-interior angles. Now, I'm just going to introduce you to the other variation on this. I said this was a class of angles. So I'll do another transversal. Here's another transversal. Now, we've got this angle here. And of course, this angle over here. So these two, in the same way as the two inside angles add to 180, these are called co-exterior angles. Co-exterior angles are supplementary. Are also supplementary. Now, we don't really deal in this course for co-exterior angles, sorry. So I'll put co-interior angles supplementary, comma, I'm just going to put comma parallel lines here, comma parallel lines. Here we go. So you could deal in that if you want. That would be perfectly acceptable. It would be unusual for someone to actually recognize that within the confines of this course, because it's not something we do. But anyway, that's what co-interior angles are. And you'll recognize them in all sorts of ways. You also, now that you've got all three types of angles, have numerous ways of getting to other angles. So let's say, for example, if I've got a transversal here, and let's turn this into some kind of a triangle, that would be useful. Now, we can now use our knowledge of a lot of these different angle types, along with angles on a line, angles within a triangle, angles that are vertically opposite. So, for example, I might have A and B. These are vertically opposite. Then I might have B and C. Well, B and C are corresponding, but C and A are alternate. Yeah? So now, for example, we might add in an extra factor. We might say, what about this angle here? Let's go angle, I've got B and C. Let's call it angle D. Here we go, angle D. So angle D now, of course, you could start to say, well, these are angles within a triangle. So now if you know angle A, and you know, for example, the angle, let's say, this one here, well, these two are going to be vertically opposite as well. So CD, let's call this angle E. So let's say now, if you were to say, I know this angle here, and let's call this angle F, well, suddenly you've got angles on a straight line, and this angle here must be the supplement to these two. So angle pairs, these angles and this one form, if you like, a pair, a supplementary pair. So you've got lots of different ways of now adding these up and describing them. Of course, angle G is this angle over here, and angle G now is co-interior to F, just like angle H is co-interior to C, and so on and so forth. You could also say, if you know E and C, you could use angles on a straight line to find angle H as angle I. Of course, angle I is now vertically opposite to angles over the other side here. So these two angles together are vertically opposite to angle I, and so on. So lots of different ways which you can combine these and add these and talk about these, as long as, of course, you're always talking about these in terms of being angles between parallel lines. Okay, well, I hope that makes sense, and go to it. Try a few.